Launch Director.
Launch vehicle is ready to launch.
We have ignition.
You have permission to launch.
1, and liftoff. Liftoff of the United Launch Alliance Atlas V rocket.
Mach 1, execute. And we have an indication of spacecraft separation.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the USS F-7 mission of the 6th X-378B orbital test vehicle flight for the Department of the Air Force. Good morning and welcome to Cape Canaveral Air Force Station in Florida. I'm Tyler Strickland, a trajectory engineer from ULA's mission design team. We have two 10-minute windows available today. The first opens at 9:14 a.m. Eastern and the second at 10:52 a.m. The count is currently in a planned 30-minute hold. There are two planned holds in our nearly 7-hour launch count. The holds give our team additional time to resolve any issues prior to entering the terminal count. At this time, the team is not working any issues, and we are proceeding towards an on-time liftoff. This morning's launch is part of the America Strong series, a collaborative salute from the Space Force and ULA to recognize healthcare workers, first responders, and other essential personnel. We'll talk about this more in a few minutes. Jessica Williams, the 45th Space Wing's weather officer, recently briefed the launch team on current weather conditions here at Cape Canaveral. The probability of violating launch constraints is 10%. The ground winds are 10 to 15 knots out of the northwest, and the temperature is 77 degrees Fahrenheit. So the weather is much better than we had yesterday, and it is within the launch commit criteria and looks favorable for the planned T0 of 9:14 a.m. Eastern. At the request of our customer, this morning's live coverage will conclude following confirmation of engine start on the Centaur upper stage. In addition to the orbital test vehicle, today's flight also includes Falcon Sat 8, an educational platform for cadets carrying 5 experimental payloads that will be operated by the Cadet Space Operations Squadron from the U.S. Air Force Academy and sponsored by the Air Force Research Laboratory. We also have 2 NASA experiments to study the results of radiation and other space effects on a materials sample plate and seeds to grow food. And we have an experiment from the Naval Research Laboratory to transform solar power into radio frequency microwave energy, which could then be transferred to the ground. Let's take a look at events from liftoff through main engine start. And liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 engine ignites and generates 3.83 meganewtons, or 860,200 pounds of thrust, to lift the rocket away from the pad. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path, while minimizing the pressure the vehicle experiences during flight. Within the first couple minutes of flight, the Atlas V reaches Mach 1, the speed of sound. Approaching payload fairing jettison, the Atlas V is burning propellant at a rate of 719 kilograms, or 1,585 pounds per second, traveling more than 9,500 kilometers, or 5,900 miles per hour, and located 112 kilometers, or 69 miles in altitude, and 116 kilometers, or 72 miles downrange. During ascent, the X-378B orbital test vehicle is protected inside a 5-meter diameter payload fairing. This 2-piece shell encapsulates both the Centaur upper stage and the X-37B. Once the vehicle is climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. Following jettison of the payload fairing, propellant levels deplete and the booster engine shuts down. Following booster engine cutoff, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs a little more than 15% of what it did at liftoff. The Centaur main engine is then started to begin second stage flight. Following main engine start, Centaur continues on to deliver the X-37B to begin its classified mission.
ULA is using the Atlas V 501 configuration to launch the X-37B. This is the 84th flight of the Atlas V rocket in ULA's 139th mission. Produced in ULA's 1.6 million square foot factory in Decatur, Alabama, The 501 is comprised of a common core booster powered by an RD-180 engine and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C1 engine. A RUOG 5-meter diameter payload fairing protects the X-37B orbital test vehicle during ascent. On April 23rd, the Atlas V first stage was transported to the Vertical Integration Facility, or VIF, at Space Launch Complex 41, where cranes lifted the 33-meter or 107-foot-long booster onto the Mobile Launch Platform, or MLP. 2 days later, the pre-assembled interstage adapter, Centaur upper stage, and lower half of the payload fairing was delivered to the VIF and lifted atop the Atlas V booster. The stacking of the rocket was completed on May 5th, when the X-37B, encapsulated in a payload fairing, was mated to the Centaur. Atlas V launch countdowns begin with moving the rocket from the VIF to the pad. At approximately 10 a.m. Thursday, the quarter-mile trip began using 6 components to complete the 20-minute trip. Weighing in at about 2 million pounds, the Mobile Launch Platform, or MLP, supports the rocket and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the rocket. At the rear of the convoy, the portable environmental control system provides air conditioning to the payload and rocket. Finally, trackmobiles provide the power to move the convoy. The Atlas V rocket stands about 60 meters or 20 stories and weighs about 346,000 kilograms or 760,000 pounds fully fueled. The X-37B orbital test vehicle is an experimental test platform managed by the Department of the Air Force Rapid Capabilities Office. Let's take a look at this unique program.
2019 at the forefront, touching down, speeding ahead, setting records for time and orbit. This is the X-37B, our country's only reusable spaceplane. Project and pride of the U.S. Air Force and Boeing. It launches into low Earth orbit and stays there as needed for as long as it takes to get the job done. The X-37B has ensured America's superiority across air and space, and it's come home again and again and again. Poised to advance and grow, meeting critical challenges, it flies safely, autonomously, and sustainably. This is innovation moving humankind forward. This is the X-37B.
United Launch Alliance has successfully launched 4 previous orbital test vehicle missions. So let's look back at those missions as we count down to the next one. On April 22, 2010, the first flight of the Atlas V 501 rocket successfully launched the maiden flight of the orbital test vehicle for the U.S. Air Force. Launched on March 5, 2011, the second OTV mission for the X-37B program was in support of space experimentation, risk reduction, and concept of operations development for long-duration and reusable space vehicle technologies. On December 11, 2012, ULA's Atlas V rocket again successfully boosted an X-37B into space. The rocket's 5-meter diameter payload fairing protected the OTV during an atmospheric ascent, and the Centaur upper stage injected the payload into the desired orbit. And ULA's 4th OTV mission launched on May 20, 2015, from right here at Cape Canaveral. As we continue to do our part to slow the spread of COVID-19, protecting the health and safety of the launch team is a top priority. We continue to follow CDC and local guidelines, including increased physical distancing between individuals sitting on console and wearing face coverings where practical. As I mentioned earlier, the USSF-7 launch carries a special dedication. Together with the Space Force, ULA is honoring healthcare workers, first responders, and other essential personnel on the front lines. And with this launch, we also stand in solidarity with those personally suffering or experiencing loss due to the virus. America Strong is a national salute to all those that have given so much during this pandemic. The Department of Defense and United Launch Alliance salute each American serving on the front lines in our fight against COVID-19. We are all in this together. Following liftoff, a few special guests will share their perspective on the role of our heroes in this fight. With today's flight, the Boeing OTV spacecraft team also wishes to remember one of their own, who recently lost his battle with cancer. Vinny de la Torre was a key member of the OTV propulsion team, who served on the launch and recovery teams for more than a decade. Thank you, Vinny, for all you did to make Boeing and the OTV successful.
OSM, verify the FCO, RCO, and OSM hold fire switches are in the proceed position.
Ready to proceed.
Redline monitor, verify redline monitor and event table are in the correct configuration for terminal count.
Verified.
RC, verify solar radiation acceptable for launch.
Verified.
L minus 9 minutes.
Before we pull the team, let's watch a quick message from Leanne Corrett, President and CEO of Boeing Defense, Space, and Security.
To everyone supporting today's historic launch of the X-37B, thank you. On behalf of the entire Boeing company, I want to express my appreciation for your work to achieve this critical mission. Since the X-37B's launch in 2010, it has shattered all expectations. Every time it launches into space, it achieves firsts. And there is no other program that provides our nation an unrivaled capability to rapidly test and integrate new space technologies. None of these achievements would have been possible without your hard work and dedication. Good luck today. Thank you for everything you do. Stay safe and be well. Go Atlas, go Centaur, go SF-7, and go X-37B.
All steps are complete prior to the status check.
We remain in the planned 30-minute hold as we continue towards liftoff. In a few moments, launch conductor Dylan Rice will pull the launch team for the final go to pick up the countdown. 29 engineers and managers are pulled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, in the U.S. Space Force Eastern Range. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Dylan Rice performs the final polling of the launch team.
L minus 7 minutes.
Status check to proceed with terminal count, Atlas systems, propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion. Go. Pneumatics. Go. LO2.
Go.
LH2. Go. Has-gas.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
TCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilical.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. ALC. Verify T0 is set for 1314 Zulu.
Verified.
Polling is complete and the ULA launch team and the Space Force's mission director are go for launch. From T-minus 4 minutes until launch, you will be listening to Dylan Rice and his team performing the final steps in the countdown procedure. You will hear the team call out that Atlas liquid oxygen topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute and 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. At T-minus 1 minute and 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, Atlas tanks will be verified at flight pressures followed by verification of Centaur tank pressures. A final status check of Atlas, Centaur, and USSF-7 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear Rob Kesselman providing launch vehicle ascent data.
L-minus 4 minutes, 30 seconds.
SMD, transfer spacecraft to internal power.
Roger.
All steps complete prior to terminal count.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
Mark. The time will be T-minus 4 minutes and counting. 3, 2, 1, mark. T-minus 3 minutes, 55 seconds.
The countdown clock has resumed and we are go for launch at 9:14 a.m. Eastern.
T-minus 3 minutes.
Securing LO2 topping.
Atlas tanks to flight pressure. T-minus 2 minutes, 50 seconds.
Spacecraft on internal power.
Roger.
FCS internal.
T-minus 1 minute, 59 seconds.
Vehicle internal.
155.
Launch sequencer start.
150.
Securing Centaur LH2. Securing Centaur LO2.
T-minus 1 minute, 40 seconds.
Launch enabled.
137.
FCS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
T-minus 1 minute, 20 seconds.
OCU's armed.
FCS count started.
115.
Reduce ECS for launch.
Roger.
110.
Vent valves locked.
T-minus 1 minute.
Rock, report range status.
Range green.
T-minus 40 seconds.
Table at step 3.
Seconds. 25.
ECS reduced for launch.
Status check.
Go Atlas.
Go Centaur.
Go Space Force 7.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. There's ignition. And liftoff of the United Launch Alliance Atlas V rocket with USS F-7 for the United States Space Force on a mission dedicated to America Strong.
Good. RD-180 has gone to closed-loop propellant utilization control.
You are hearing the voice of Rob Kesselman providing launch vehicle ascent data.
The pitch yaw roll program. Vehicle body rates look good. Now, 35 seconds into flight. Atlas is now just under 1 mile in altitude, traveling at 900 miles per hour. Engine pump speeds and injector pressures are in family for this thrust level. The vehicle has now completed the pitch yaw roll program. Now 70 seconds into flight. Atlas is now 4 miles in altitude, 0.4 miles downrange distance, traveling at 1,200 miles per hour. Vehicle has passed Mach 1. Vehicle is now passing through maximum dynamic pressure, max Q. RD-180 is now throttling down slightly as commanded. Pump speed response looks good. Now 115 seconds into flight. We're now 14 miles in altitude, 5.6 miles downrange distance, traveling at 2,000 miles per hour. The vehicle has now begun closed-loop steering. The vehicle is now half the weight it was at liftoff, burning propellant at a rate of more than 2,600 pounds per second. Approximately 2 minutes remaining in the Atlas booster phase of flight. Sensor reaction system is now pressurizing flight levels. Atlas is now throttling to maintain 2.5 G acceleration limit. Now 180 seconds into flight. Vehicle is 44 miles in altitude, 40 miles downrange distance, traveling at 4,500 miles per hour. Approximately 1 minute to BECO. Standing by for payload fairing jettison. With indication of payload fairing jettison. And Centaur forward load reactor has also jettisoned successfully. Atlas is now throttling up to a 4.6 G acceleration limit. Centaur has begun the boost phase chill down sequence. Atlas is now at 4.6 Gs and maintaining that acceleration limit. EU has gone to closed loop control. Boost phase chill down is complete. We have BECO, booster engine cutoff. Standing by for stage separation. Stage set, we have successful stage separation. Restart on the RL-10. We have ignition, MES 1. Centaur has now begun the first of 2 RL-10 burns in today's mission.
Recently, I had a chance to speak with Boeing's Jim Chilton about the X-37B. Jim was over in Boeing's Mission Control Center at the Kennedy Space Center. Let's take a look. Thanks for joining me, Jim. As you know, this is a special launch dedicated to first responders. Would you like to address that to kick us off?
Hi, Tyler. Thanks for having me. And by the way, thanks for getting another great Atlas V to the launch pad to give us a ride. I would like to respond that in these challenging times, it's never been more clear the importance of first responders to our whole society. I'd also like to add a thanks to the women and men in uniform, because our U.S. defense posture hasn't changed and they haven't backed off a bit either.
In the context of this being a classified program, what can you share with us about what the X-37B is and does?
Well, X-37B is a really interesting machine.